So can you find the area of the shaded region of this shape? Pause the video and I'll give you a couple seconds. Okay, so this composite shape is made up of circles, squares, and right triangles. So how can we find the area of our shaded region? Of course, we're going to find the area of the triangle on the left and the right. However, the center gets a little bit harder in that there's a portion of our circle that's missing. We also have this additional triangle here where we'll need to find the dimensions to add that area in as well. However, before we just go ahead and do this, let's notice a relationship between this triangle up in our circle and this triangle right here. Notice that their angles are marked to be congruent to one another. And also note that the side length is marked to be congruent to one another. Therefore, by angle side angle, we can say that these triangles are congruent. So if you can imagine erasing this shaded area and then putting it in, transposing it over to our circle, what we really have to do in order to find the shaded area of this composite figure is to find the area of our left and right hand side right triangles and to find the area of this circle. And that's it. So now that we've simplified this problem, let's tackle it. So first, on this right hand side right triangle, notice that both the legs are congruent to one another. Therefore, the angles opposite the legs must also be congruent to one another. Therefore, we have a 45, 45, 90 right triangle. Now you remember that your 45, 45, 90 right triangle has legs of some side length x and your hypotenuse of some side length x square root 2. Therefore, our side length of this triangle must have a value of 8. And so our side length of our square is also 8. Moving into the triangle within our circle, we can see that it is also a 45, 45, 90 right triangle, as the two legs of this triangle are radii of our circle, and the hypotenuse is given to be congruent to the side length of our square, and so it also must be a value of 8 right here. So what is our radius? Well, we can again use our 45, 45, 90 right triangle. We're simply going to set our hypotenuse, that's x square root 2, equal to 8. And then we can solve for x to give us our side length. So we'll solve for x by dividing both sides by the square root of 2 and have 8 over the square root of 2 is equal to x. And then we can, this is an improper fraction, right? We can't have a rational in the denominator. So we can multiply both our numerator and denominator by the square root of 2. And then we are left with 8 square root of 2 over 2. And of course, 8 cancels with the 2 to give us 4. And so our side length, or our radius, is equal to 4 square roots of 2. So let's write that up here. Our radius is equal to 4 square roots of 2. Next, we need to find the length of our square so that we can find the area of this triangle on the far left. Here, let me change color for us. Go to this purple color. So notice that it's marked that this side length is congruent to this part of our square, of our larger square. However, we need to find the value of the total length of our larger square. Well, again, this comes from us knowing that the triangle within our circle is congruent with this triangle over here. And this is useful knowledge because remember that corresponding parts of corresponding triangles are congruent. Therefore, since both of these links in the triangle in my circle, since both of its legs are congruent to the radius, then I can say that this leg here and this leg here must also be congruent to our radius. And we know our radius is 4 square roots of 2. Here, let me go back to my orange. So this is some distance of 4 square roots of 2. And so the full distance of my square must be 8 square roots of 2, as 4 square roots of 2 plus 4 square roots of 2 is 8 square roots of 2. So this smaller segment is the 4 square roots of 2, as it's congruent to my radius. Now I have all the little leg segments needed in order to find the area of the pieces of my composite shape. So for this triangle on the right, what do I have? I have 8 times 8 divided by 2, base times height divided by 2. 8 times 8 is 64. 64 divided by 2 is 32. So this segment has an area of 32. What about for the triangle on the left-hand side? Well, I have 8 square roots of 2 times 4 square roots of 2, all divided by 2. We could go ahead and cancel the 8 and the 2 in the bottom to leave us with a 4 up top. And so we have 4 square roots of 2 times 4 square roots of 2. 4 times 4 is 16. Root 2 times root 2 is 2. So 16 times 2 is 32. So this triangle over here on the left is also has an area of 32. Lastly, what's the area of my circle? Well, we know that the radius is 4 square roots of 2. And we should know that the area of a circle is pi times the radius squared. And so pi times 4 square root 2 squared is going to be equal to what value? Well, just in the bottom, we just did 4 root 2 times 4 root 2 and found it to be 32. And so the area of our circle must be 32 pi. So let me go ahead and just write that in here. This must be 32 pi for the area of my full circle. Therefore, the area of all of my shaded regions added together is going to be what? Well, notice that they all have a factor of 32. Here, let me move this here. Let me move this over, or I'll shrink it up a bit. So the area of my full shaded regions is going to be 32 plus 32 is 64 plus 32 pi. You could, of course, put this into a calculator, or you could factor out a 32 and have 32 times 2 plus pi. Either way is great, and either way is the area of the shaded region. If you found this video helpful, give it a thumbs up and subscribe to the channel, and I hope to see you in the next video.